This is the third of 3 videos that I'm recording for section 5.3. So in the previous 2 videos, I've introduced restrictions and gone over the basics of solving radical equations. This video is just going to focus on some more advanced radical equations and seeing some more specific cases of things that we're going to run into. So if you haven't already gotten introduced to these equations and don't know how to solve them yet, make sure you go back to the previous 2 videos to get a sense of what's going on. All right, so let's just dive straight into things. So we're going to solve this equation. At first glance, doesn't look particularly difficult, right? Probably even easier than some of the ones I did in the last video, but let's go through things and see how it goes. So remember, the first thing we want to do is isolate our root, which means that -3 at the front has got to go. So I'm going to divide both sides by -3, which is going to get me root 2x minus 7 equals -1. We're going to square both sides, which is going to get me 2x minus 7 equals +1. And we can add 7 on both sides. Oops. And then we're going to divide by 2 after that, which is going to get us our solution of x equals 4. So that wasn't so bad. Don't forget we need to do our restrictions. So 2x minus 7 greater than or equal to 0. We add 7 on both sides. 2x greater than or equal to 7. We divide by 2. And we get x is greater than or equal to 7 over 2. And we stop maybe here for a second and say, okay, is 4 bigger than 7 over 2? It is. 7 over 2 is 3.5. So our solution's all good on that end. And then we need to do our checking. So you got -3 times our root of 2 times 4 minus 7 equals +3. All right. So remember, we're not moving stuff to both sides of this equation. We're not solving. Remember, there is an impenetrable wall here. Nothing gets through. We are just calculating. So 2 times 4 gets me 8. And 8 minus 7 gets me 1. And the square root of 1 is 1. But -3 times 1 does not equal +3. It equals -3. And so these don't match. And that's a problem. Our solution here isn't actually a solution. It's a fake solution. So x equals 4 is not a solution to our original equation. It was a solution somewhere along the way, and I'll talk about what that means in a sec. Oops, got an extra a in there. So is not a solution to the original equation. It's a fake solution, and it has a name. So we call these kind of solutions extraneous. So it is an extraneous solution or extraneous root. Either one of those is pretty common. And an extraneous solution is a solution that got introduced by something that we did in our solving process. It's not that we did anything wrong. We didn't. We solved this perfectly. It's just that something we did along the way changed the equation in a fundamental way that made things different. So if we scroll back for a second and you look at this, you might notice that at a certain point, this equation just very obviously didn't work. And that was right here, where we had a root equaling a negative number, but a square root's never going to give you a negative answer. That can't happen. But when we squared both sides to get rid of the root, suddenly we got rid of the negative, and this became +1 instead of -1. And that is a problem. So our extraneous solution got introduced when we squared both sides of the equation. So this particular solution or this particular equation rather, doesn't actually have any solutions. So no solutions. Sometimes we're going to see cases where we get maybe two solutions and only one of them is extraneous. So that's fine. But in this case, we only had one solution. It was an extraneous solution. So there's just nothing that's going to make this equation work. And again, we know that because we have a root that equals a negative, and that's just never going to happen. So there's no way to make this thing work. So this is why we have to check our equations every time, and we have to check our solutions every time, because you don't know if your solution is real. It might be an extraneous solution. So we've got to check every single solution to make sure that we're getting a solution that actually works. All right. So introduce something new to our radical equations. What happens if the variable pops up in more than one place? So say here, where suddenly now we've got an x outside of our root. So we don't want to isolate that x. We don't want to solve for this thing. Keeping in mind what I said in the last video, we still want to start by isolating not the variable, but the root. So let's go about doing that. So we've got root x plus 8 minus x equals 6. So if I want to isolate that root, that x has to go to the other side of the equations. So I'm going to add x on both sides. Which gets me root x plus 8 equals x plus 6. So I've isolated the root. That's great. And same as before, to get rid of the root, we are going to square both sides. But when you do that, if you look at that x plus 6, if you square that, you are going to have to do something specific, and that something is FOIL, right? So when you square both sides, when you have that x plus 6 over there, you have to FOIL that. It's going to be a really common place for people to mess up. So we've got root x plus 8 equals x plus 6. We're going to square. On the left, that just cancels out. That's great. So we've got x plus 8. But on the right, if we do x plus 6 squared, you got to remember that's x plus 6 times x plus 6. It's not just x squared plus 6 squared. And so if you FOIL that carefully, you're going to get x squared plus 6x plus 6x plus 36. Or if you simplify a little bit, x squared plus 12x plus 36. So let's go ahead and put that back in to our equation. And so it's great. We've gotten rid of our root. It's not a radical anymore. But this isn't just a basic linear equation like all the ones that we've solved previously. This is a quadratic equation. And we have to solve it as a quadratic equation. So if you think back to chapter 4, we covered 4 methods of solving quadratics: graphing, factoring, completing the square, or quadratic formula. We're not going to graph this. That one's definitely out. And we're typically not going to complete the square if we don't have a reason to. So most of the time we are either going to factor if we can, or we're going to use the quadratic formula if we can't. But before we can even do that, remember, when you're solving a quadratic equation, you've got to make sure that one side of that equation equals to 0. So our first step here has got to be to move that x and that 8 to the other side of the equation. So I'm going to subtract x on both sides, and I'm going to subtract 8 on both sides, which is going to get me x squared plus 11x plus 28. And so I'm going to try to factor this if I can, because factoring is faster and cleaner than the quadratic formula. If I can't factor, I would use the quadratic formula. But in this case, this one is factorable. So remember, we want to find two things that multiply to 28 and add to 11, and that is 4 and 7. So this factors to x plus 4 times x plus 7, which gets me my solutions of x equals -4 and x equals -7. If you don't remember how to solve by factoring or how to solve by completing the square or quadratic formula, make sure you go back to the chapter 4 videos that cover all those topics and just do a little bit of review. All right, so we've got solutions. Let's look at our restrictions. So we had x plus 8 is greater than or equal to 0. I don't care about that x that was outside of the root. I only care about the radicands. So if we move that 8 to the other side, we get x has to be greater than or equal to negative 8. And both of our solutions are, so that's good. Now when we check, we have to check both of these solutions, but we have to check them separately. So you're going to check one thing at a time. So I'm going to check negative 4 first. So if I plug negative 4 in, and I have to plug that negative 4 into both of those x's that came up into the equation. So I'm not going to plug negative 4 into one and negative 7 into the other. You do everything with negative 4, then you do everything with negative 7. Oops. Oh, I made a little bit of a mistake here. That shouldn't be negative 4 plus x. That should be negative 4 plus 8. So let's fix that. All right, so negative 4 plus 8 is going to get me positive 4. If we subtract negative 4, remember that's going to turn into an addition as well. The square root of 4 is 2, and 2 plus 4 equals 6. So this is all good, right? Our solution works when x is negative 4. Now we're going to try the other one. So I'm going to try this with negative 7 now. Okay, so negative 7 plus 8 gets me positive 1. Subtracting negative 7 gets me plus 7. And you might already notice that something's not going to work here, right? So if we square root that 1, we're going to get 1. And 1 plus 7 gets me 8, not 6. So this one did not work out. And so what we'd say is, at the end, to summarize this question, x equals negative 7 is extraneous. So you do have to do that. You do have to explain that you are rejecting one of the solutions because it didn't work. And the actual solution is x equals negative 4. And there we are. So again, that's how we get two solutions to these equations, because that can happen. Except we only got one solution that actually works. Sometimes both of them will work, sometimes neither of them will work. Or sometimes, like in this case, one of each. All right. Trying something a little different now. Now we've got two roots. Thankfully, this one is pretty straightforward. We're going to see a more difficult one after this where there's more involved. But when you've got two roots equal to each other like this, we've already isolated each of the roots, so we can actually just go straight to squaring both sides. But this only works when you have a root on each side and nothing else. So we square both sides here, we get x plus 6 equals 2x minus 3. And now we just need to solve. So keep in mind, when you're solving equations that look like this, when you have x's appearing in more than one place, it's not quadratic, there's no square. So you don't want to necessarily move everything to one side. What you do want to do is move everything with an x to one side and everything without an x to the other side. So I'm going to subtract x on both sides here to move that x to the right. And then I'm going to add 3 on both sides to move that 3 to the left, which is going to get me x equals 9. We do our restrictions. And so we've got 2 restrictions here, right? So we've got 2 roots. Each of those roots is going to give us its own restriction. So the one on the left gets us that x has to be greater than or equal to negative 6. And then the one on the right, if we do it fully, gets us that x has to be greater than 3 over 2. And so when you have 2 restrictions, honestly, if you're at least working with me, just list out both of them and you'll be totally fine. But technically, when we're thinking about these restrictions, we have to take the one that's more restrictive. We have to find something that fits both. So if I put, say, negative 4 in as an x value, negative 4 is bigger than negative 6, but it's not bigger than 3 over 2. So the actual restriction is really just this one on the right, because anything that fits that one is going to fit the other one. You might also have cases where you have to be in between a couple of values. So you got to think of it for yourself, what actually fits the roots that you've been given. Now we check our solution. So if we plug our 9 in for x, on the left, we're going to get the square root of 15. And we do it on the right. We're also going to get the square root of 15. And so our solution here works. Everything's good. All right, one last question, but this one is going to be quite difficult. This is probably the hardest thing you're going to see in this chapter, and it's something that tends to cause people a lot of trouble. It's going to be an equation with two roots, but it's not just going to be a root equals another root like the last one. There's going to be more going on here. So, in a situation like this, remember our first step when we're solving radical equations is to isolate our root. But how do you do that when there's two roots? So the long and short of it is, if there are two roots, pick one and isolate it. It's your choice. It won't make a huge difference in the long run. You should get the same answer regardless. So just go with whichever one seems easiest to you. Maybe one of them has nicer numbers. Who knows? So for me, I'm just going to isolate the one on the left here. For no particular reason, just because it's on the left. So to isolate the root on the left, we just need to move that 2. So I'm going to subtract 2 on both sides, which is going to get me root x plus 4 equals root 5x plus 2. And we've isolated both roots, which is great. We've isolated one of the roots. And so just like usual, we are going to square both sides. And we are going to have to FOIL. And this messes so many people up. You have to remember to FOIL here. Right? If you don't FOIL, you are not going to come close to a right answer. So on the left, if we square root x plus 4, remember that root's just going to cancel out. Nothing big going on there. That side's pretty easy. The side that you isolated is pretty much always going to be very easy, because if it's not, you didn't isolate it properly. On the right, though, we have root 5x plus 2 times root 5x plus 2. And so we have to FOIL that thing properly. So we're going to do root 5x times root 5x, root 5x times 2, 2 times root 5x, and 2 times 2. That first one is really crucial because it's something that people kind of tend to forget. Remember, if you're doing root 5x times root 5x, we talked about this back in the multiplication lessons, that just cancels out, and that just gives you 5x. Then we've got 2 times root 5x a couple of times, and then 2 times 2, which is 4. That one's easy. Now you'd want to simplify this as much as you can. Maybe you can combine some like terms like we can in this case. So 2 root 5x plus 2 root 5x is going to get us 4 root 5x, and I'm also going to move that plus 4 at the end up, not for any particular reason, just because it looks better to me. And so that leaves me here. So let's put this back into our equation and go from there. All right. So now we're back to here. This is now just a radical equation with one root. And so our goal here now, just like any radical equation, is going to be to isolate the root. But now we're isolating the other one. So we isolated the root x plus 4. We got rid of it. Now we want to isolate the root 5x and get rid of that. In the same way that we've been doing for all of these other equations. You just have to be really, really careful with what you're doing here. So we're going to subtract 5x on both sides. We're also going to subtract 4 on both sides, which is going to get me negative 4x. The 4's have just canceled out. And then that equals 4 root 5x. Last thing we want to do before we keep going, we're going to divide both sides by 4. And that's going to get me negative x equals root 5x. Now don't stop yourself here and say, oh, hey, we've got a negative on the left, this won't work, because there's a variable here that changes things, right? If that was a negative 2, this wouldn't have any solutions. But since it's a negative x, we can maybe make things work out. Let's find out. So we're going to square both sides, because we've isolated our root at this point. So on the left, we've got x. On the right, we've just got 5x. Oh, sorry, on the left we should have x squared, rather. So we're going to move everything to one side of the equation because this is quadratic. So we're going to subtract 5x on both sides, which is going to get me x squared minus 5x equals 0. And so we can solve this by factoring, or we could solve it by quadratic formula, but factoring is a lot easier because if you look at this, both of those terms have a common factor of x. So if we just take the x out, we get x times x minus 5 equals 0, which gives us two solutions of x equals 5 or x equals 0. So if we look at our restrictions, we have either x plus 4 is greater than or equal to 0, which gets us that x has to be greater than or equal to negative 4. Or we have 5x is greater than or equal to 0, which gets us that x has to be greater than or equal to 0, right? Because you're going to divide both sides of that by 5. Both of our solutions are fine with those, so now we just have to check them. So go ahead, check both your solutions here, see what you come up with, and then come back and see if you agree with what I come up with. Okay, so we've got, I'm going to check 5 first. So root 5 plus 4 plus 2 equals root of 5 times 5 plus 4. Well, 5 plus 4 gets me 9. 5 times 5 gets me 25. Square root of 9 is 3. And 3 plus 2 is 5. The square root of 25 is 5. And 5 plus 4 is 9. Well, 5 doesn't equal 9, so that's no good. That solution is going to be extraneous. If we try the other one, plug in some zeros, we get 0 plus 4 plus 2, and the square root of 0 times 5 plus 4. Well, 0 plus 4 is 4. And the square root of 4 is 2, and 2 plus 2 is 4. On the right side, 0 times 5 is 0, the square root of 0 is 0, and 0 plus 4 is 4. So hey, that one worked out. And so what we've come up with then is that the solution on the right, which was 0, that one works, but x equals 5 is extraneous. And there you go. So those are radical equations. If you're still having a little bit of trouble, make sure you go back and look at some of the earlier ones to get a good sense of those before you come back to this. And then in the next couple of videos, I'm going to go over how to graph radical equations, which isn't something that is in your textbook, but is really important for your course. So take a look at those 5-point X videos to find out how to graph radical equations.